Dear attendees, good afternoon. Welcome to the session 2. I, Gurpreet Kaur Bhular, on behalf of Physics Department, Mata Gujri College, Fatehgarh, Sahib, taking the pleasure to welcome Dr. Dinesh Pathak. Dr. Pathak is a well-renowned and world-famous personality in the field of science. In the morning session, he delivered a well-planned talk on basics of nanosciences and nanotechnology. And in it, he discussed about the nanoscale level and explained well with the examples from daily life. He also throws a light on the fact that there is a plenty of room at the bottom. Sir has discussed about the surface defects in condensed matter physics and grain boundaries and how defects change the properties of materials about the quantum confinement and quantum dots. So now I request Dr. Pathak to kindly start the session 2. So may I take the liberty to start the session?
Thank you, Dr. Gurpreet. I'm happy to listen your voice after many years when you was at Thapar University during 2012.
Yes, sir. Thank you, sir.
And I got information yesterday that you are also in the same college with Dr. Navjeet. So thank you once again. So
Thank you,
as
sir.
introduction, thank you. As we were talking in the morning that what is nanotechnology, nano and technology, and the idea, nanoscience, and then science is working for technology. So there are so many examples where we see that when we reduce the size of any material within the range 1 to 100 nanometer, then properties changes very drastically, and obviously when the properties are changing, then applications will change.
Connection lost.
Is it okay? Should I continue, Dr. Gurpreet? Am I audible?
Yes, sir, you are audible. You can continue.
Oh, you said in between that connection. So I think if in between the connection is lost, then please message me on WhatsApp, because if you will call me, then again there will be problem because I connected it with the mobile.
Okay, sir.
So field, one specialized field of nanotechnology, which is named as nanofibers. Actually, when I worked for around 4 years in Czech Republic, after completing my postdoc, I was working in a company which was producing nanofibers. And nanofiber is a very specialized field related to nanotechnology. And even when we see, actually last year has witnessed, 2020 has witnessed a very potential challenge to mankind. We all know that we were forced to remain in our houses in isolation because of COVID-19 and because of the potential high risk of viruses. So, and everyone is forced to wear the mask on their face from morning to evening, from duty time to in the market or everywhere. So the mask which we are wearing, they are related to normal fabric, and they cannot filter the small viruses which has size around 100 nanometer or less. So there are one special kind of mask are also available in market. If you will go to market, you can buy nanofiber based masks. So on this special branch of nanotechnology, we will discuss today that what are nanofibers and what can be their applications. Nanofiber market is the field has already reached, the market has already reached around 400 to 500 $1 million worldwide. So what are nanofibers? in this present PPT, you may be watching that in the top we have a scanning electron micrograph of material which looks like threads. So if you will see by naked eye, you will see nothing, because they are the fiber. These are the material which are having fiber-like structure, and the fiber diameter is less than 100 nanometer. So again, it is very basic to understand that you cannot see these materials by naked eye, but when you will examine these material under influence of very high resolution electron microscope or scanning electron microscope, you will see structure like this. Fiber-like structure, fiber-like microstructure, or further if the size is more or less than fiber-like nanostructure. So the in-between zones which we say here in this scanning electron microscope, they are named as pores of material actually. And if we can control the pore size during synthesis. So for example, if we wish to filter water, and we are purifying the water from the lead and other heavy elements, then we can fix during synthesis we can have porosity in related to that. For example, if you wish to filter corona is not a new virus. There are plenty of research paper available starting from 2010 to till now. So if we wish to filter corona, the novel coronavirus is expected to have size around 120 nanometer, as not much. This is not much explored virus, but the idea which people took is they say that the virus size is around 120 nanometer. So if the porosity will be less than 120, the virus will not cross through it. So there are so many applications related to nanofibers. What we can do is, in the left side here we can see, sorry, in the right side here we see is we have two to three layered, or that can be two to three layered mask, where in between we can put a layer of nanofibers, and then we have some cloths are in the outer regions. So they means this is one of the application of nanofibers. So today we are going to discuss about nanofiber, what can be their applications, and what actually they are. So nanofiber are the normal materials, but when we see those under the influence of high electron microscope, the structure looks like fibers. So they can have fiber, they can have diameter from 1 to 100 nanometer. Their properties are very different from their mother materials. So they can be of polymer based material, or they can be the blend of polymer and metal oxides. These are some applications of nanofibers. They can be used in wound dressing. For example, if you will go to a hospital with some wound, they will clean your wound and they will put some dressing over it. So we need dressing material of such a way, of such type that air should go through inside, because air help in healing the wound. So air should penetrate, but on the same time, the medicines or the liquid drops which the doctor give you on the wound, that they should not come out. So nanofibers can help in that. Similarly, we can have sensor based applications, then optical in applications in optoelectronics, then in filtration, in cosmetic. So there are so many plenty of applications of nanofiber based material. So why nanofibers? Their porosity can be tuned. They have many applications. Depending upon the application, we can fix the porosity. Later I will discuss that how porosity can be controlled and how the different diameter. Two things helps here. One is the diameter of the fiber, and second is porosity. For example, if we have a air filter, then air should go through it, but other chemicals or other pollutant or even the viruses, they should not go inside that. So we can fix the porosity like that. If we are going to filter the water, then pure water should cross through it, but heavy elements should not through it. So just based during synthesis, we can just Okay, we can fix, we can it means we can change the porosity, and then hence the applications. So nanofibers can be made up of either from polymer or a blend of polymer and the the inorganic materials. Diameters can be controlled either by controlling the solutions concentration or so many other ways we will discuss further. So these are some properties of nanofiber. They have very high surface to volume ratio. Porosity can be tuned. This is the major thing which we need to do depending upon the application. For air filtration, air should go through the pores, but not the other elements. So we can control the porosity. We need control to control the porosity in that way. If we are going to filter water, then water should go, other things should not cross through it. If we are going to control the various viruses, either novel coronavirus or Hanta or so many other viruses, Ebola, so we can fix the porosity according to that. Means we can fix the porosity of the size of the more than that virus. So these are some ways that why the nanofibers are helpful. So now how the nanofiber, how these types of nanostructure can be produced, we have method. First is drying, then electrospinning, then template based synthesis, then force spinning. Actually, force spinning is a method where you put the solution in a chamber and you rotate it, and there are nanopores actually on the side, and then we can produce a nanofiber. Similarly, we have, I just used in my work which we started last year, electrospinning method. So electrospinning is a method where what we do is that I will show you first of all instrument. This is the method. This is the instrument actually. We put the solution in injection here, and we give opposite potentials to the different sides. Like if we are going to collect the fibers on the collector here, we will give it a negative potential, and on the syringe or the solution we will give positive potential. So when you will give two opposite potential in this system, then thread like electrically charged threads, they will get collected. They will get collected over the collector, and we will have fibers then. So this was the machine. This is installed at. This is actually Indian made product, and this is installed at Guru Nanak Dev University with one of our colleague there, and so we can produce nanofibers like that. So again, coming to the applications part, now one question may come to your picture that in your mind that how to control the porosity. So porosity can be controlled by just changing the potential or changing the distance between syringe and this collector, or maybe changing the concentration or pH value of this. So depending upon the application, means if we are going to make a filter for some viruses, then we need porosity according to that. If we are going to change the if we are going to filter the water, then we need the porosity of the size equal to the water, so that water can go through it, but other things will stop there. So just means this is a very simple way to understand that means depending upon the application, we need porosity. So we can control porosity from here, just either by changing the potential or changing the distance or changing the concentration of the solution or changing the pH of the solution. So again, this slide is dedicated to application. So we here produced the nanofibers with the blended organic material blended with the titanium dioxide. So just I put some points here that why we use titanium dioxide. Actually, if we produce fibers of pure polymer, then that will not have much good strength. And obviously, we all understand that when we made a device, then obviously it should be mechanically withstandable. Mechanically withstandable means it should remain, because we need to, for example, if we need a mask, so it should have some good strength, otherwise it will destroy even after one use. So that is why means some inorganic materials, they can be blended So we, owing the good properties and low cost of titanium dioxide, we blended titanium dioxide with the organic polymer. So just we used PPP and ethanol as a to make one solution. Then this TTIP, this is the precursor of titanium dioxide, to make the second solution. And then both solutions were mixed, and they were stirred for 45 minutes. This is just now, when you perform some experiment, we don't prepare only one sample, because one sample will not give you any justification of that. So what we do is we prepare series of sample. Like here we prepared 3. We change the concentration of this polymer, then weight percentage, then ethanol, and this is for second solution. And then we mixed both solutions, and we stirred it for around 1 hour, and then a gel-like structure, gel-like material was obtained. And just to give you just this data, that how we fix the parameters. So this is not done by, this cannot be done by one way, by doing first time. First, maybe we have put the voltage 11 kilovolt, then RPM around 350. RPM is the rotation of this drum. Actually, this drum on which the fibers are collected, it rotates with the uniform speed. So it is a rotation per minute, 350, then flow rate of solution, then this volume, distance of this syringe from where the solution is coming to the drum, over the drum. So you can vary it, means you can vary the distance, you can vary the time, you can vary the rotations. So then when you will vary these things, then different porosity and different diameter of fibers. So but then later you can project them for some application. So when the fibers are collected over here, then we need to see that actually if the fibers are formed or not. So how that can be done? We did this scanning electron microscopy. So here you can see very clearly that fiber-like structure was formed. And here in the first sample, when you see first sample to second sample, second to third sample, the diameters and porosities are different. So obviously, if the diameters and porosities are different, then obviously the applications will be different. So my idea to show you here this is that when you change the parameters means, just going to the previous slide, parameter means you're putting some solution here. So solution, those who know about chemistry of solutions, then obviously you can change the solvent, you can change the pH value. pH value is actually a parameter which gives us if the material is neutral, if the material is acidic or basic. You can change the molarity and normality even. And you can also change this distance of this syringe to the drum. When you will change the distance, the diameter and porosity will change. Similarly, you can change the potential which you are applying here. We applied here a potential around this 11 kilovolt. So similarly, you can change this RPM, which is written here, rotation per minute, 350. You can do it 200 rotation per minute, or maybe 300 or 400. So when you will change all these parameter, the porosity and diameter which I am showing here, diameter means these fibers, and the in between the voids which we are watching here in the scanning electron microscope graphs or micrographs. So when the diameter and porosity will change, the applications will change. Similarly, you can explore plenty of other materials. So these type of structure, when they are observed by naked eye, you will see that these materials are same. But when all materials are same, but when you will see under high resolution electron microscope, then you will see that they have different porosity and different diameters. So this is just for 3 sample. Plenty of materials and plenty of inorganic organic blends or plenty of techniques, other techniques, they can be explored, and you can have different porosity. And different porosity means different application. For example, if you wish to filter novel coronavirus, which restricted our life in last year, if you wish to stop that, you need a porosity of around 100 nanometer. As people say that this material has size of 210 nanometer. So if you will have a nanofiber structure of porosity less than 100 nanometer, the coronavirus will not will not penetrate to your mouth, and that can save you. That can prevent the passage of novel virus infection. So again, what we see here is this is the just concentration. We found porosity around 4 nanometer. This in the third column you can see 4 nanometer, 2 nanometer, 1 nanometer. So 4 nanometer or 2 or even 1 nanometer, this porosity is quite excellent. Oxygen can go through it, but the other viruses, even dust has size of around in micro to bigger size. But I am saying here to stop the viruses which are of the size of few nanometer. So with this you can stop. Just we also done some X-ray diffraction, but this is not important here because then we are just using the fibers for filtration. Structure is not important, means either it line doesn't matter. But when you are using these fibers for some optoelectronic application, in some device, then if the atoms are arranged or not, then that matters. So that can be seen with the X-ray diffraction. However, we say here that they are amorphous. X-ray diffraction is a technique actually which was discovered by William Bragg and Henry Bragg, and they got the Nobel Prize. This technique discovered by Bragg and Bragg, and this is the only Nobel Prize in physics which was given to father and son. So this is also named as father-son Nobel Prize, and the son was only 25-year-old at that time. So this is also one of the youngest physics Nobel laureate prize given to a father-son combination. So it means just you can see in detail, maybe in MSc you are studying what is X-ray diffraction. X-ray diffraction is a technique which is used just to distinguish that if the material is ordered or not. If it is disordered, there is no diffraction, means no pattern, and X-ray diffraction, before the discovery of X-ray diffraction, it was not possible to see if the material is ordered or not. So just means we also did, and we found that the material is disordered. There is also one technique to see porosity, which is BET technique. What we do here is, in this technique is we just expose material with some gas, and the gas is adsorbed on the surface, and then it is dissolved. And by having analysis of these graphs, we can see the porosity also. So this was done actually at IIT Mandi. They are having this machine. And then we plotted, we just made a table. The porosity is the same as observed from the surface analysis by scanning electron microscope. We found that the porosity is 4 to 2 to 1 nanometer, which is quite good to prevent the viruses which are having size more than this. And see here, this is not important, but I will show you. We also filtered water with the help of these nanofiber, and see here that we were able to purify water. This is before filtration, and this is after filtration. But actually, these fibers stopped the dust particles, but I'm not sure if they were successful in stopping the lead and arsenic. But yes, we filtered the water as a preliminary experiment. So water filtration is also a very big challenge, because with the growing in population day by day, we need to give access to pure water to the mankind. And I'm in hilly area, we have pure water already, that we have natural resources, but as you belong to urban areas, so urban area, in urban area, providing water challenge to the population is very difficult challenge. We have many other methods like reverse osmosis, which we name RO, and chlorination, or in the older time the normal technique. But nowadays this water filtration by nanofiber is also very famous, which is the coming, which will be the coming technology, because it will be very cheap. Nanofibers are very cheap. They are just made from polymer and or inorganic blend. So you can filter water. Yes, in future maybe you will have nanofiber filtered filtration possible. So see here that we obtained porosity 1 to 4 nanometer. And when you see the toxic element, they have also size in comparison to this. Water has less size, water molecule has less size than this. Then some this in the lowest column, you can see that the few harmful viruses like Ebola, COVID, SARS, bird flu, Zika, and other Hanta new virus which was coming. There was a rumor that one more virus is coming from China virus. They have size from 40 nanometer. So if in future, if we will have commercialization of masks made by sandwich means two cloths in the side, and in between we have this nanofiber. So obviously, if the porosity will be around 1 to 10 nanometer or 5 nanometer, these viruses will not reach your lungs and or in the inside the body, and they will be helpful to stop the spread of infection. Yeah. Conclusion is that I think I already discussed about water filtration. This I discussed. Yeah.
Yes, sir.
So then I was saying that means the challenge in nanofiber based industry is that we need to produce industrial scale products, then we need to do commercialization, then because industry don't need 1 or 2 centimeter scale nanofibers, but industry need that in maybe in kilograms or in tons. So these systems which I have shown you here, they are more or less related to the laboratory scale. There are some bigger electrospinning and force spinning machines also which produce nanofibers in kilograms. So means I said earlier that all of you maybe maybe belonging to chemistry or physics. So this nanofiber industry need good chemist and good physicist who can control the porosity, diameter, do commercialization. And then, so if you are going to join research somewhere in future, then I suggest you that you can choose nanotechnology and especially nanofiber, because in future the nanofiber based industry will be very bigger and will grow bigger and bigger worldwide, because they are very lightweight material. The water filtration, air filtration, and other applications are very wonderful. So I hope that in this lecture you followed that what are nanofiber, what are the applications of nanofibers, how they can be produced, what can be their application. Just the thing which is important here is porosity and diameter. And porosity and diameter can be controlled during synthesis, either by changing the electric field here, especially in electrospinning, or by changing the concentration, pH value, or maybe the distance or electric field which we apply to the different terminals in this specialized instruments. So these all things, they need to be explored more and more, so that the different porosity fibers can be obtained, and hence commercialization. They are already in market. You can buy a nanofiber mask in around 100 rupees. There is a company in India which is named as Swasa. So in 100 rupees you can buy a nanofiber mask. Maybe you have seen many politicians including Modi, Prime Minister of India, wearing the Swasa mask, because that company, the e-Swasa, they are commercializing that product by this way. So means this is not a new field, but many more things to be done. But things needs to be done. More control, better control of porosity, better control of diameter, and then commercialization of nanofiber, which will change the future world. So if you will have some question or queries, we can discuss here, and or you can mail. I have also given my mail ID in the morning, Dinesh Pathak 80@gmail.com. If someone from you needs some guidance after your master degree, you are already having very good teacher, Dr. Navjeet and Dr. Gurpreet Bhullar, and many others may be there. But still, if you need my guidance or discussion, I will be happy if you will contact me or mail ID or even phone you can get from Dr. Navjeet or Dr. Bhullar, and I will be happy to answer you. And I hope you followed this small lecture which we just on the research which we just started last year with one of my MPhil students. And I hope you understood that what is nanotechnology, what are the various applications of nanotechnology, how nanomaterials can be synthesized, what does tuning in nanomaterials means. Tuning means changing the size, porosity, diameter according to our desire and according to the application, which a conventional material cannot do. A conventional silicon material, with a conventional silicon material, conventional means size, when the size is quite bigger, the properties remains as it is. But when you change the properties in nanorezyme means a rezyme from 1 to 100 nanometer. The diameter from 50 to 60 will change the properties very drastically. See, but in micromaterials, it is not like that. So that is why nanomaterials are very important. They are tunable, actually, tunable. For example, when you listen in the morning, the radio, FM radio, you just tune the radio and a new station comes. So that in the same way, if you change the size of the material in less than 100 nanometer range, the properties becomes very different. Like in the morning, I have given you one example that of the gold, you can have a red gold, blue gold. You can have a silver of a blue color or maybe red color. So if the band gap can be changed, the color can be changed, hence the applications. So similarly here in nanofibers, if you change the diameter, you change the porosity, the application changes. And they have very tremendous applications which are going to come in the future. And the world is waiting for you, the people like you, the smart people who can help in synthesizing new materials for the betterment of mankind, for moving the world to a better place. So I hope you understood. And Dr. Navjeet, if they have some questions, then we can discuss. There are 36 people.
Sure, sir. Thank you, sir, for the wonderful lecture. Now, audience, if you have any queries or questions, you can ask. The house is open for queries.
Mr. Sandeep, he is doing PhD here. He is sitting in Jammu, but he may not have any question because he discussed the same things already with me. So maybe from your college, if you have some questions.
Students and participants, if you have any queries, you can ask freely.
Are you teaching these courses? Your college is affiliated to, I think, Punjab University.
Yes, sir. There is a course in MSc Material Science. Nanotechnology is also there.
Yeah. So maybe they are already aware the basics of nanotechnology. So
yes, sir. There is a course experimental techniques in physics in which yes, sir.
Where you teach the X-ray diffraction, microscopy, etc. All these things.
Yes, sir. All the techniques.
Yeah. So I suggest all the people, those who are interested, many may not be interested in research in future, But I suggest one thing, that there is career in science as well. Sometimes we think that that we failed to qualify the exam for to become a medical doctor or a dental doctor or a qualified engineer from IIT. But I suggest you one thing, that in science there is career as well. And but if you that required consistency, and that required the scientific bent of mind. So many laboratories in India are there, like DRDO, DST, DAE, and even State Council of Science and Technology, etc. And even you can move for PhD abroad. One of my students here who did MPhil here on just copper oxide nanostructure, he is doing PhD in Czech Republic. One more fellow who just finished this nanofiber work, he is going to join in France soon. So if you need such type of guidance or help, those who are interested, I will be happy. And if you will have, even if you will have some questions related to nanoscience, nanotechnology, nanofiber materials, and I hope you will contact me. And if not, if you already have good teachers in your department, Dr. Gurpreet Buller, she did PhD from Thapa, and Dr. Navjeet is also there. So if you will have some question, my mail ID is there on the PPT given, and then we can discuss, and I will feel happy to answer the queries. And still, if this time, if you have some questions presently, then we can discuss.
Sir, we will share your email ID as well as contact number with the students, so that
Yes.
if they want to ask questions afterward, they can contact you.
Yeah, thank you. Thank you.
Or you can guide them in future also.
Yeah, thank you. Thank you.
Thank you, sir. Thank you so much. Now I am handing over the mic to Ms. Ritika to present the vote of thanks. Thank you, sir.
Thank you. Thank you.
Ritika Arora, on the behalf of Physics Department, Mata Gujri College, Fatehgarh Sahib, would like to thank our esteemed speaker, Dr. Dinesh Pathak, for sharing a wonderful session on nanofibers. Dr. Pathak has explained well about the nanostructures, application of materials for nanofabrications. Our speaker explained about how in this scenario, in COVID scenario, we can fabricate some nanomaterials. And our speaker has also explained about the like how we can prepare the materials at the nanoscale level. Again, I would like to thank you, sir, for sparing your precious time with us, for excellent PPTs and making this workshop interesting.
Thank you. Thank you once again. Thank you. We will meet again, maybe after COVID. If situations may become normal, I will be happy to visit your college and your colleagues. Thank you.
So now we will meet in offline mode only.
Yeah. Thank you. Thank you once again. Thank you, Dr. Gurpreet. Thank you.
Thank you, sir.